Hello guys, we'll be having a look at a quick overview on WebRTC, web real-time communication. And yeah, so I listed other words we'll be looking at. So yeah, we'll be looking at the definition of WebRTC, how WebRTC works, a preview of that. Then we'll look at network address translation. It's quite important if you want to really understand how where some parts of WebRTC works, you know. And then we'll explain the terms that are related to WebRTC, terms that you need to know that you can't escape. Then we'll have a quick demonstration. And then somewhere in there, I also have a more detailed explanation of how WebRTC works. You get, so we'll have a preview, explain the terms, and then have a more detailed explanation. So yeah, let's get into this. I'll just turn this off and leave my screen on there. All right, so let's have a look at the definition here, and we'll get straight into it. So you see, WebRTC is a technology that enables web applications and sites to capture and optionally stream audio or video media, as well as to exchange arbitrary data between browsers without requiring an intermediary. Okay, so yeah, it helps us to exchange data between browsers directly without an intermediary. So usually, if you want to, let's say, send a message to someone, you do that through, say, Twitter, through their DM feature, messaging feature, or if you want to have a video call, for example, on WhatsApp, you'd have to do that through the WhatsApp video call feature. So that's an intermediary there. But with WebRTC, we can actually do all of this directly from the browser to the other person's browser without any intermediary. So that's what WebRTC is. Examples of companies that use that. Let me just show you. Use WebRTC. So Google Meet, they use it for streaming for Google Meet. Yeah, basically. So you can see Mozilla. Well, usually it's standard. So most browsers have this in their browser so that it can be used. But companies that use it, okay, yeah. Let me open this, or let me just zoom in here. So it says we have Google Meet down there. We have Discord, yes, Discord down there. So a lot of companies that deal with streaming data, video, or audio use WebRTC. So most companies use that. So yeah, I'm gonna close that and then let's go straight into this. Now let's have a preview of what WebRTC is, and then I'll try to explain some things needed for you to understand how WebRTC works, and then I'll show you, like I said, I'll demonstrate, show you a quick transmission of the data. All right. So why do before I get into that, why do we even need WebRTC in the first place? So like this said, it says it allows transmission of data without any intermediary. So this means that we can send data without having to rely on some middleman that's going to send my data to the other person. So it helps to send data faster with low latency, and that's one of the beauty of WebRTC. You can send data faster without having to rely on the speed of some server or something else. So yeah, you can check more on. I do recommend that you check more on why we have WebRTC and maybe a bit more on that. Yeah, so let's have a look at the preview. So the way WebRTC works is that, say you have a device A, let's say my device, and I want to connect with your device. Say I want to have a video call with you, or maybe send some data with you, but then I don't want to do that via a server because of the speed. So now I want to connect to you, and then what would happen is my device will find all the possible ways that I can be connected to, right? So the same as your device, it will do the same thing. And then when it gets those possible ways, they exchange those with each other so that they can communicate. So if I'm going to get my own possible ways of in which other people can communicate with me, right? And then I'm going to send that to you somehow. It could be through WhatsApp, through DM, any other way. It's not going to be via WebRTC in the first place, right? So when I send this data to you, you would also do the same thing, send the data to me, And then when I have that, I can now communicate with you via that medium that you send to me, the data that you send to me, which are the possible ways that I can connect with you. Yeah. So that's how WebRTC works. Device A wants to connect, device B wants to connect. They find the possible ways that they can be connected to, and then they exchange with each other and then continue with the connection. Usually they'll pick the best way out of the possible ways that they can be connected to, right? So let's have a look at NAT, yeah, which is network address translation. I didn't write that in full. Let me write that here for you to see. Network address translation. There we go. Yeah, so that's the full meaning. Now, what is network address translation? It's a way of translating your private IP to public IP addresses for communication. Now, someone who's not really acquainted with what public IPs or IP addresses mean might get confused here. So I'm advised to check that, but I'll talk about it a little here. So when you are when you have a PC or any device, you always have what you call a private IP address, and that private IP address is the way for you to be able to be identified on the internet. It's for your device to be identified rather. But then when you want to go on the internet, you need what you call a public address, a way in which other people can find you on the internet. So if you want to connect on Facebook, you can't connect to your private IP address, right? You need what you call a public IP address. Usually that's given to you by your internet service provider or your router, stuff like that. You get. So it's just a way for your IP address is just a way for you to get pinpointed or located on the internet. People usually call it your address on the internet. Yeah. So now network address translation is just a way for your private IP address to be translated to public IP address so that people can locate you, right? So that's what network address translation is. Now let's look at the different ways this happens, because they are really important to understand how WebRTC works and how you might encounter some roadblocks when working with them, and probably ways to go around that. Now, there are four types of network address translation methods. You have the full cone NAT, which is also known as one-to-one NAT. You have the address restricted cone, the port restricted cone, and then the symmetric network address uh, translation. Now, so what is full cone NAT? Full cone NAT is basically saying that uh, so I have a diagram here I prepared for this so that I can try as much as possible to make it easier for you to understand, right? So don't get overwhelmed with this. Just follow along with me and you get that. You get this rather. So you have a device A right here, right? And I want to connect with, say, device B over here. Now what happens is this is my private IP address. Okay, let me move this to the side a bit. Let me go full screen. Yeah, there we go. This is better. So I have my private IP and I want to connect with this device right here. So this device's public IP. Now what would happen is when I try to send data to this device, my router here will say, okay, you're about to go out there to the internet, this world where you have a lot of things, crazy stuff out there. So it's trying to protect you. So what it will do is take in your public IP address and then your public port there and translate it to a public IP address. Usually it would use its own public IP, its own IP address, yeah, and then generate a port for you. So when you generate this port, that would be your public address and public port. Now, it would using this address, it's going to send data to this particular device here. Uh, Now, this particular device then would receive it. Now, the thing with full NAT is that once you send data to this user, right, this user can say, okay, I want to send data to you, and then just send data to your public IP address as well, and you receive it. But now, full NAT means that anybody who also knows your IP, your public and IP address and your public port can also send data to you. Yeah, so if any other stranger sees this and say, okay, there's someone device, this is devices A public IP address and port, they can just send data to you directly. That's what full CONAT is. No much security on that, no restrictions. Data can be sent to you once your IP address and your port is known. So what is our address restricted code, right? Okay, let me check a bit here. Okay, so address restricted code or restricted CONAT. Now this is saying that if I want to send data from device A to device B over here, of course my IP address, private IP address, gets translated to a public IP address and port, and then I send data to this user here on this port. Now address restricted code is saying that if device B wants to send data to me, my router will check. Every network, every request to device A will go through the router, right? Because this is how I'm accessing the internet. So device A's router will check, have I connected to devices B, this current device that is trying to send something to me before? Have I sent data to that device before, or IP address? So it's going to check the table and say, okay, I won't send data to this device via this public address, right? And then it's going to receive your data. But if this device here tries to send data, it's going to check. So let's ignore all of this part here, right? Let's ignore this for now. So let me delete it. In fact, uh, yeah. Oh, sorry about that. Okay. So if I try to send data from this public IP here, then my router will check, have I sent data to this IP address before? No. So automatically that would be a failure. There wouldn't be any data transmission between this and this because I have not sent data to that particular port, to that particular address rather. So when it comes to port restricted CONAT, it's the same thing, except that the router would only receive connect requests from a device which data has been sent to. Okay, but it would also check the port. So basically what I'm saying is it will only receive data from devices that from a public address and public port that it has sent data to previously, right? So if I try to send data from, let's say, 19 this public address on ports, okay, let me draw an arrow here. So I try to send data back to this device A, yeah, or let me duplicate this. So if I try to send data on this same public address but on port 2000, then my router would say, okay, I've received data from this address before, but not from this port. So it's going to reject this connection, right? Because it is also port restricted. Port checks for both the address and the port. So if this even tries to send data at all, let's say it wants to send data from here to here, it will automatically be a failure because it doesn't even recognize the address in the first place. So that's not going to work as well. So that's port restricted CONAT for you, right? I'm going to cancel that. Yeah. So now let's go into symmetric NAT. I'm going to reverse and add stuff I added. Okay. Oh, I've made a lot of changes. I want to add this back here. Okay. So let me have a touch on restricted and port restricted um, CONAT again with this particular data. So if I send data to this particular IP, to this device, to this public IP, and I try to send data back on a address restricted CONAT, would it work? Think about it before I say the answer. Uh, so I try to send data from here to here on address restricted CONAT. Yeah, it would work because I've sent data to this public IP address before, and the port wouldn't matter. But if I try to send data from this same IP address, right, but on a different port, let's say I want to send on ports, let's say 5000 for example, then it's not going to work because I'd never sent data to this public address and this port 5000. I only send data to, oh sorry, that's mapped to the wrong place. So I've only sent data to 12346. and not 5,000. So that wouldn't work, right? Uh, Now for symmetric NAT, the difference is that between symmetric NAT and port, they are kind of similar. Yeah, symmetric NAT, when it wants to, it sends data just the way others sends data, but then when it wants to receive data from any of these devices, it checks, have I received data from this destination address? Have I also it's also going to check for the ports, but then it's also going to check for the public address and the public port. So if you think about this for a while, you begin to ask yourself, so what's the difference between symmetric and port restricted CONAT? Because if my device would also always be giving this public IP and port, the difference between them is that symmetric NAT does not always use the same public port for every connection. So if I want to connect to device A, for example, device B, for example, it can connect on port 1000, yeah. But now if I want to connect to this same device on another port, yeah, this will change. So this might turn to something like, let's say 1500, which means that if I want to send data from this device to 1100, but if and I send it on port, let me say 12344, right? So let's say I want to send data from IP address on this port 12344. Then my router is going to check, okay, have I sent data to this public IP and this public port? Then if so, it's going to check, have I also did I send on this particular public address and on this particular port in which this router is trying to send to? If it's true, then it's going to accept the request, but which means that's successful, right? But if I try to send data to this here on this port, but to this particular IP address and this particular port, what my uh, router will check the NAT table and say, okay, have I received data from this address and port? Okay, that's true. But then remember, you send data to this public address and this public port. So the router is going to say, okay, if you are sending data to me on this, I'm expecting your IP address and your IP port to be this. So it's going to reject this connection, even though your public IP address and your public port is registered on the NAT table, which would work for restricted CONAT, right? So that's kind of the difference between restricted CONAT and symmetric NAT. The difference is basically that in symmetric NAT, you would not be using the same port for all your connections. So in the case of a device where you're sending data via different ports, you cannot send data to the same device on different ports. You have to keep sending data back on the same port. So it's kind of more secure, and that's causes some form of restriction. No pun intended. Some kind of restriction on how you send data via WebRTC. It's quite secure, and that's a good thing. So now let's move on to the next thing here, which is ICE candidates. Yeah, ICE candidates. So we've talked about now translation and local the private IP address, public IP address, and your port, and that helps with communication of data or packets. So now, what is ICE candidates? So okay, you know what? Let me zoom out, and before I come into this, I'm going to come here and use this to start the explanation. So ICE candidates, ICE. We're going to start from ICE before we move on to the candidates. So ICE. Interactive Connectivity Establishment is a framework that allows your browser, the framework to allow your web browser to connect with peers. There are many reasons why a straight up connection from peer A to peer B won't work. It needs bypass firewalls that would prevent opening connections, give you a unique address if, like most situations, the device doesn't have a public address, and relay data through a server if your router does not allow you to directly communicate with peers, to connect with peers. Now we can see we can pinpoint some things from here. So it allows you to communicate with peers. So it means this is very important when you're dealing with WebRTC, when you want to connect. Okay, because this is when I talked about your device getting the possible ways you can get connected to. This is what facilitates that, your eyes, right? It gets the possible ways, and what are those possible ways? So your your IP addresses, it's very important, or relay addresses. So I'll get to that. And also it says there are many reasons why shoot up connections from pair A to pair B won't work. And yeah, so that's why I talked about symmetric NAT. That's an example, you know, and I'll take you there to understand how that might be an issue, and then there might be firewalls. So it gives you a unique address and so on and so forth. So you can come here and read more on this. Uh, so what's ICE candidates? So basic ICE candidates are the ways you can get connected to, right? So you can, if you're trying to communicate with a device on the same network, your local address is a way you can get communicated to. So when you're on the same network, you don't need a public IP address, right? You just need a way to get connected to, and that's your local address too. It's also a way of getting connected to on a local network, which I would say is usually the best way on a local network. So your reflexive address as well, which is also your public IP address or port, host, your public IP address and host, right? No, sorry, this should be port, right? So that's also on that we can get connected to and relay the addresses. Okay, so this is usually gotten from a stone server, and this is usually gotten from a ton server. So we'll get to that in a bit. So we've said ice candies are the ways in which you can get connected to your local addresses, your public IP address and port, or your relayed addresses. Now let's talk about how do we actually get this, right? You say we need this to communicate, but how do we get this? And that leads us to the stone server, which is short for session traversal utilities for NATs. Okay, so utilities for NAT. So it's a protocol that discover your public IP address and determine any restrictions in your router that will prevent a direct connection with a peer. So don't get intimidated by this. Is just the name is just, I don't know why this is the name, but yeah, that's the name. It's what the stone basically does for you, right? It's usually a server. There's a stone server. Okay, it just basically tells you your public IP address and port. So let's say this is the server here, like I did here, right? And you need your, remember I told you in the preview that you need possible ways you can get connected to, and one of the ways is to get your local addresses. You can get that by on your PC locally to get your public address and your public port. Now, your public address and your public port cannot be gotten locally. You need to get that from your router or when you want to connect on the internet. So to do that, what you can do is connect to another device. So that device is going to check, okay, where is this connection coming from? Then it will detect your IP address and your IP port and then forward that back to you. So that's what a stone server does basically. Then when it forwards it back to you, you have your public IP address and your port. Okay. So I think this is step 2 on the possible ways you can get connected to. Getting you possible ways you can get connected to. Yeah. So this is step 2 on the preview of how WebRTC works rather. So now the same device bit does the same thing, asks the stone server for the possible ways it can get connected to, then its IP address also will return to it. So that's how you get your public host, through a stone server. Yeah, there are a lot of free stone servers on the internet. Even Google has free stone servers that you could use. You can also build your own. They are not what they do basically just give you a public address. So they're not expensive, right, to run. So expensive. Um, so yeah, that's what Stone does for you basically. The protocol is a protocol that gives you a way for you to get your public IP address. Yeah, your public IP address and this and determine any restrictions. So anything that has to do with, well, we'll get to that too. So just follow along with me and yeah. So now what is session description protocol? SDP, right? Also going to have a look at it from here. Okay, we have it here. So it says it is standard for describing the multimedia content of the connection, such as resolution, formats, codecs, and this and encryption, etc., etc. Now these names are big. They might sound big to you if you're just getting to know this WebRTC for the first time, right? So session description protocol is actually not a protocol. It's just usually it's a string that contains the kind of data your device can send, the resolution, the format. So if device A can only receive work with sounds that are .wav format, for example .wav, okay, then it's adds that in a string, right? So what also it also adds your ICE candidates in a string, your candidates. So when it does this, that's what your session description protocol is. It's just a string that contains the kind of data you can deal with, the resolution, the encryption, and then your ICE candidate. Okay, it's even here. SDP, funny enough, I didn't really look at this. I didn't look at this second paragraph. So then SDP is not truly a protocol, but a data format used to describe the connection that shares media between devices. Yeah. So remember I said that you're going to send the possible ways you can get connected to, right? So when you get your ICE candidates, you're not going to send the ICE candidates directly. You're going to combine the ICE candidates with what you call an SDP, and then that is what you send. So when you create an offer, it automatically generates an SDP, which will contain the ICE candidates and all those other things I mentioned on here. And then yeah, it's not really a protocol, it's a string. So the thing with SDP, yeah, so that's SDP basically. It's just a string that helps with transmitting or sending data. Yeah. So now let's move on to signaling server. So signaling server is just basically a way for you to send the data, the SDP, and other important data for connection. So when you've gotten your ICE candidates, you've gotten your you've generated your SDP. Now you need to find a way to send it to the other user, because remember your SDP is the possible ways you can get connected to. So when you get that, you can send it to the other user via what you call a signaling server. Now we're not using WebRTC for this yet, right? We are just trying to establish a WebRTC connection, and that's one thing about WebRTC. You don't just connect like that. So you need to make use of a signaling server to exchange this possible ways of getting connected to, and then when you get connected to, you can start the peer-to-peer connection or transmission of data. And remember, I said this would be a WhatsApp, the message via DM. Usually, it's sent via WebSocket. Okay, you can create a WebSocket connection in a server and help to use that for the connection. You can also use HTTP connections for that as well. But yeah, usually WebSockets are used. Okay, so you also use web signaling server for sending ICE candidates, right? Triple IC. Now you might be saying that you might be thinking that, but wait, I mentioned that you add your ICE candidates to the SDP. So why am I mentioning this differently? So the thing with WebRTC is that when you want to create your SDP for the first time, so when you're creating your SDP, you create it in the form of what you call an offer. So that offer contains your SDP. So that SDP, your web browser will find the possible ways it can get connected to as fast as it can, so that it doesn't waste time, and then it sends that over. So in the process of getting the data that it can find as fast as it can, you should probably just say get your local IP address and send it over. But then your it will keep trying to get your public IP address and probably your related addresses as well. So in the process of doing that, WebRTC does not wait for you to do that. It just sends the candidates it can get as soon as possible, as well as the data format. And then when this arrives, it also sends that via the signaling server. So the signaling server would also receive those and then update its data it has, the possible ways it can get connected to that it has about you, right? So yeah, so when both devices or peers receive the possibilities you can get connected to, so it's going to pick the best ICE candidates, yeah, and then establish a connection through that. So that's what signaling server is for, basically just to exchange data to establish a peer-to-peer connection. And then after that, you're not going to be using the signaling server as much as you did at the beginning. But though the signaling server will still be there in case of a change in network or something like that, so that it can update the ICE candidates and send to the other pair. Okay. So you also have your turn server. I'm just going to come on here for turn. So turn is the way we try to deal with symmetric NAT, right? Okay. So routers using NAT employs restriction called symmetric NAT. This means that the router will only accept connections from peers you have previously connected to. Now, so turn is meant to bypass the symmetric NAT by opening a connection with the turn server and relaying all your information through that server. So you wouldn't necessarily be communicating directly, okay, from peer A to peer B. You'd be doing that via a turn server, which is would be kind of faster compared to, of course, slower than when you're communicating directly, but faster with your normal signaling server. Now, why is that so? For my explanation of the way symmetric NAT works, say you get your public, remember you need your public address to be able to connect to any device. You need the device's public address to be able to send data to them. You can't send data to their private IP. So when you get your public address, right, and you send this via a signaling server, which is not in this diagram, to peer B, and peer B does the same thing, right? Now, when you try to communicate directly by sending data to peer, let's say peer A wants to send data to peer B's public IP. When he attempts to do that, right? Let me use this diagram. So when it attempts to do that, remember the router of peer B, for example, will check: have I connected to this public IP? Have I sent data to this public IP and ports? Right? Right? And then on a particular external public IP and port. So if you come back to this diagram up here, yeah, so it checks: have I sent data to that public IP and ports on a particular public IP and port? So the answer is going to be no, because remember you only send data to your Stone server and not to this device. So your port for this particular server is going to be different from your port for this server, which this server is going to be sending to you. So that wouldn't work. Yeah, so I hope that's kind of clear. If you have any questions, please just drop them down below. I know this is not something you can teach in a. Sometimes it takes time to explain how this really works. So before you understand it, but yeah, I'm trying to do that as much as I can in a short time. Okay. So that's all. Now let's go into the detailed explanation right here, so that we can have so this is going to give us an overview of everything, kind of what we've talked about and how the connection actually works. Yeah. Okay, so yeah, so I want you to clear your mind. And okay, I think I need to put my phone on silent. Yeah, I hope those sounds were not disturbing. Now let's have a look at this from the start again. We have the preview, and then from my explanation of all those terms, you probably guess that the connection is more detailed than this. So let's have a look at this, and then we'll have the quick demonstration. So device A wants to connect to device B, all right? Okay, let me do that. So device A wants to connect to device B. Now, device A, which is peer A, gathers all its ICE candidates, local candidates, stone candidates, or the turn candidates. So peer B does the same thing. So remember that your peers might not get all the ICE candidates that's available at the moment. It tries to get as much as it can, and then when they do that, peer A, for example, in this case, creates an offer, and then it sets it locally. So an offer would usually contain your SDP, right? So when it creates that offer, it sets it locally for itself and then sends it to peer B through a signaling server. Peer B will receive this offer, okay, configure it locally, and then based on that offer, it creates what we call an answer for it. So that answer would also contain its own SDP. Then sends this answer locally, set the answer locally for itself before it also sends it to peer A. So you can see that this peer A creates an offer, configures it locally before sending to peer B. Peer B receives that offer, creates an answer for that, sets its answer locally before, and also sends it to peer A. So yeah, you're creating offer and creating an offer and then sending it to peer B, and then peer B receives that offer, creates an answer from that, and also forwards it back to peer A. So ICE candidates, the ICE framework performs a connectivity check on each candidate, local and reflexive, in the SDP. So remember your candidates are in the SDP, so you try to connect with them. Of course, no connection has been initiated before, so restricted connect restriction will be there because no connection was there before today. You had not connected to that device before. So that, but remember, even though there's a restriction and the connection does not go through, a mapping is created on your NAT table. Okay, I remember. So when it performs this connectivity check, it does not try to connect with the device. It does not connect with the device on the first candidate. It just picks the best one, the strongest one for connection. Now, when peer A receives peer B answer, okay, this is after peer B has generated an answer and sent it over. When A receives a peer B answer, it configures it locally, and ICE candidate performs a connectivity check like peer B did to make sure connection is possible, starting from local to reflexive candidates. So in the process of that, it also creates a NAT mapping on your NAT table and verifies connection, because when it now tries to send to the other device, now there's a mapping on the other device, because remember when they received your offer, they also try to perform connectivity checks, which also created a NAT mapping for them. So this connection will go through even on a restricted NAT, since PB has a mapping already. So note that as new candidates are detected during this process, they will also be set locally, which means your SDP will be updated, and then via your signaling server, those ICE candidates, not your SDP now, those ICE candidates will be forwarded to the other peer via the signaling server. So as you are performing your connection, or even when the call has started, the connection is established. If new ICE candidates come in, they will also be forwarded to the other peer via signaling server. And ICE candidate performs connectivity checks on that too. So remember again, the ICE candidate, the most efficient candidate is selected for connection after the connectivity checks. So now that the connectivity checks have been performed and device A can connect, if device A or peer A can directly connect with peer B, right, then the connection will be established and then A and B can communicate directly. Otherwise, turn servers are used in this case, and then data is just relayed between pair A and pair B. Okay, that's quite a lot. I'll agree with you on that. Okay, so you can always have a look, come back and have a look at this. Ask questions in the comment section below. And one of the reasons why I'm discussing this is because I might possibly create a video on this in the future. Yeah, a project on this in the future. Now that's the detailed explanation. Now before I go to the concise, let's have a quick demonstration of WebRTC. And yeah, so I'm going to open this here. Let me write console. I'm going to open an incognito tab beside this. Just open the developers to here. So usually you'll be doing this in an application, but you can also do this inside directly with JavaScript. You can do this in your browser as well. So I'll start with creating a new peer connection. So to do that, you need to do, so we're going to do something, say we're going to say local connection is equals to peer connection. Okay, so you need to put new there, connection. Okay, so new RTC peer connection. So this is our local peer. Okay, so you can name it whatever you want. I just want to call it peer. So when you do that, you have your local peer. Now remember, you need to create an offer. But before we do that, what we're going to do is we're going to create some listeners. So we're going to say your local peer dots. When you receive an ICE candidate, we want to know when an ICE candidate is coming so that you can see that as well. So when we receive an ICE candidate, okay, okay, I'll just do this. So when we receive an ICE candidate, we're going to say consider log SDP. We're going to log updating SDP and then print out your local description. So when a new candidate comes in, your SDP gets updated. Remember that, and then we're going to log your SDP. But then your SDP is usually in what you call local description. So when new eyes comes, you want to do that. Also, when there's a change in your connection change, yeah, on connection state change. So okay, I'm going to use this. So let me expand this. Okay, that's the highest. So then when the state in your connection change, you want to console.log connection state change and then the connection state. So when a new connection is created, you will see that a new connection was created. When the a connection is established, we'll see that as well. So we know when connection has been established and you can start sending data. So I'm going to add that event listener. And then finally, I want to create a way we can send data via text. So we can do that with what you call a data channel. Yeah. So to do that, we're going to say lp dot create data channel, and then I'm going to label it out as chat. You need to put a label in there. And then for this year, I'm going to say, uh, so now I'm going to say DC dot, anytime a connection has been opened on my WebRTC core connection, okay, I'm going to log connection open, yeah. And then anytime that a new message is detected, say from another peer, I'm going to consider log message and then the data that was sent. So that's all I need to do to set up a data channel. So the data channel is where data can be sent via text or probably some other data that's, yeah, some other data you can send in strings, as far as I know for now. But then if you want to send video or audio, you don't do that via data channel. You usually do that via tracks. So yeah. Well, I'm not going to talk about that here. I might just do some quick things to show you on that later on. So now that we've created all these event listeners, so we see what's happening in our application, let's create an offer. So we're gonna come here and say lp dot create an offer. All right, it's a what's it called? It's a promise. So we need to do dot 10. Now when the SDP is detected, remember in my detailed explanation, I said we need to set the SDP locally. All right, so remember SDP is usually stored in what you call local description. So we're going to say the local description, and then we're going to set our SDP. Now that's also a promise. So when that's done, we want to also log what to see what our SDP looks like, right? I mean, it's your first time offer created. So then we're going to do lp dot local description, and then I'm going to close that. Okay, so when I press enter now, as you can see, offer created. Okay, from this, and then we can see what the SDP looks like over here. Uh, and then when new ice candidates are detected, you can see that we are logging, updating ice candy, updating. And then if you check both of these, there will be some difference in there. Although I'm okay, and one of these will be my local address, will contain my local IP, right? Local address, and then one of this will contain my public IP. No, sorry, it can't contain my public IP because I'm not connected to a Stone server right now. So yeah, that would probably be on a future videos. You can check more on that. So anyway, um, Yeah. So now that we have our offer, we need to send that over to our other peer, remember. So I'm going to find a way to copy this. Can I? Okay, that works. That works. So I'm going to come here and then call this an offer. Okay. So now we're also going to do similar things here so we can know when the connection is established. Right now we can see that no connection has been established or connection has been opened based on this, right? No connection still change. So I'm going to paste this in here and say, okay, before we do that, we need to create our local peer as well, our remote, our other peer. So for the other peer, I'm going to call it a remote peer. Okay, so we need to do new RTC peer connection, and then we can see our remote peer. That when it gets an nice candidate, we want to see what our SDP or local description looks like, right? Also, when there's a state in its connection, when there's a change in its connection state, we also want to log that. Okay, this is remote peer. Okay, now for the data channel, what we're going to do is we're not going to create another data channel. What we're going to simply do is listen for when this one sends a data channel. So we're going to say rp dot on data channel. Okay, so if you detect any data channel from this our pair which is initiating the connection, yeah, we're going to say e. So what we're going to do is we're going to add uh, an object to this rp and say rp.dc is equals to our e dot channel. So that's going to be the channel. Now we're going to say rp.dc dot on this data channel. Anytime the connection opens, right? We want to log data channel established. Um, so anytime receive a message as well. So okay, let me just copy this. Oh, okay. I'm thinking I'm almost done typing, so I'm just going to type it. MSG as well. Data, and then we're going to close this. Yeah. So that's that for data channel. And now we're done with that, we can create our answer. So I'm going to say remote peer dot create answer. It's a promise, so we need to wait for that, and then say SDP is equals to remote peer dot set. We need to set our local description for this, right? So I'm going to set SDP. This is also promise, so we need to say that when it's done, then we're going to do let me stringify it directly here, and we're going to pass our remote peer dot local description here. Okay, so this will just show us what our local description looks like when the answer has been created. And when I press this, I've oh my goodness. So uh remember when I talked about when receiving the offer, you need to set the offer. Right, I was about to do that here, but then I forgot and went there to this. So remember, you need to follow the flow. Now, when you receive an offer, before you can create an answer, I remember saying that you need to create an answer based on that offer. So what you do is you say remote peer dot create dot set remote description. Okay, this is the way you set your offer, the offer you got from the other peer. So we're gonna put offer here. Then when you've done this, uh, this is also a promise. Okay, I think I can let me do then, alright. So log offer set. Right, so offer set. Now when you set the offer, now you can create an answer. Okay. So as you can see, that wouldn't work if you did not create and if you did not set the remote description. So of course so now I can do this, and now you can see that it says updating SDP. So I didn't add it. Anyway, that's fine. So now we see we can see creating SDP. I didn't create this here, offer created or answer created, so we could see it, but that's fine anyway. Now that we have, wait, hold on. Now that we have our SDP, we can just copy one of this. Okay, so we're gonna copy object. Yeah, we have that. So as you can see, the difference between this offer and this answer is there's a type here. This one says type answer and the other says type offer. So I'm gonna copy this already. So I'm gonna come over here, and then what I just need to do right now is say local pair dot set remote description here as well. Then I'm gonna paste this and cover. Okay, so this is also a promise. We're gonna say console.log remote answer set successfully, I guess. So let's just hope this works. So now when I press enter, we should see that connection is established. Yes, there we go. So it says answer set successfully, connection state change checking. It also checks connectivity checks, remember, and then it gets connected. Then data channel is opened here, and it is open here as well, which is established up here. All right, so now we can, oh, not that. So now we can send data. So if I do, remember, via data channel, I can do data dc dot send and say hello there, and then we receive it over here based on this listener that we set here. Okay, so we can also send message with dc dot send and say hola amigo. Okay, I can't even remember what that means. Anyway, it gets received here as well, and that's the same way you would set different kind of data as well. Yeah, so if you need to, no, sorry, if you want to send different kind of data, there are different kinds of data. So if it's audio or video, you won't be using the data channel like I said earlier. So but what I meant by that is you'd also be sending data via this kind of method. Yeah, so if you need to learn more about WebRTC, I recommend going through MDN. Okay, read on that, but you can come on their website to see examples of what you can do, know how to get your devices, info on devices like their video and audio. Okay, so let me do this here so you can see it. So if I let me play this, so if I play this here, I should get a prompt to allow my camera, this will switch my camera on. Right, I don't want that right now. And then yeah, so that's the way you, once the connection has been established, you can get your camera and then start sending it via tracks. Okay, you start sending the stream. So that's it, guys. I think it's almost been an hour. If well, I don't know, but it's been a long time when I started this video. And what matters is that you guys understand. So if you have any questions, please let me know in the description below. Even the video, if I'm creating any projects on WebRTC, I will direct you guys to this video. Yeah. Alright guys, I'll see you on the next one. Peace.